Okay, so recording has started, so we will begin with our session. So, very good afternoon to all of you once again. And today we will start with unit number 4. And unit number from beginning from unit number 4, all the contents are very essential and important, not only for the this course point of view, but also for upcoming courses, for example artificial intelligence and machine learning. And even it is important for your mini projects or mega project that you will be taking in coming semester or in next year, and even in your upcoming career. So those who are especially interested in higher education, research, job, everything, so I strongly recommend you to take this topic and try to solve as many as problems, so that you will be in a position to solve the problems related to curve fitting and regression analysis. So with this introduction I will start, and I will tell you one my experience. So since 2013, I worked on many projects, and I will tell you in all the projects, somewhere I need to tell the help of curve fitting and regression analysis. So you can imagine, since last 8 to 10 years, every month I am using the techniques that I learned in curve fitting and regression analysis. So that may be your observation after few years. Okay, so the contents are the curve fitting. In that we will see least square technique. In least square we need to understand how to prepare first order equation, power equation, exponential equation, and quadratic equation. And again, that can also be a regression analysis, where we will see linear regression, that is fitting a straight line. In non-linear regression, we have to fit a curve, for example power equation or quadratic equation or any other. Again, in linear and non-linear regression, there will be two values, for example x and y, and we will be finding out the relationship between x and y through a equation or a regression analysis. But if there are more than two parameters, then it is called as multiple regression. So these methods we will discuss in regression. Again, thereafter we will see polynomial regression, Lagrange's interpolation, and we will see numericals based on interpolation and differentiation using Newton's forward method, inverse interpolation, and especially based on Lagrange's method. So these are the some of the contents, and this particular unit will require 8 hours to complete the most of the contents. Now, the first question that comes in our mind, that why we need to develop the relationship between the two parameters, for example x and y. So first of all, we need to understand this philosophy with example. Then you may say, yes, there are so many areas where we need to develop empirical laws. Empirical laws means find out the relationship between the variables and develop model or equation for the same. And in mathematics, engineering, science, technology, it is very essential to express a given data obtained from experiments and observations in the form of a law connecting the two variables in what? So you already perform experiments in case of fluid and turbo machinery or fluid mechanics. So you were varying one value, and correspondingly you will getting some output. And then by using this regression technique, you were developing the empirical relations, and through that you are making some predictions. We will see some example. So you may be interested to develop the relationship between temperature and its effect on the length of the bar. So for example, take an example of a factory or an industry where the structural columns are made up of steel. So one of the component could be a metallic bar. So what happens in summer, the atmospheric temperature increases, and due to change in temperature, we know that the length and the dimensions, overall dimensions of the steel increases. So if there is a change in dimension, then what will happen to the structure? Because in many historical incidents, many structure fall down due to such a deformation due to increase in temperature. So whenever you are designing the steel structure or you are designing a shaft or any component, then you must understand the deformation of that steel structure, for example metal bar, with respect to temperature. So what generally did in the laboratory, suppose you develop a new material. So sample specimen is formed, and it is subjected to different temperatures, say 35 degree, 40 degree, and so on. And for each temperature, the dimensions, for example length of the bar, is measured. So as temperature changes, the length of the bar changes. So such type of data will be collected from the experiment, and once this data will be available to you, the relationship will be developed between length of the bar and temperature. And now suppose a new bar is to be manufactured, which will be applied in the application where atmospheric temperature is, or the operating condition is 110 degrees Celsius. So you already have a relation from the historical data. So in that equation, when you put temperature equal to 110 degrees Celsius, then you will come to know what will be the length of that bar. And this particular data will help you in the design of that bar. So there are such many applications where you need to use such type of theory. We will take another example. We know that if the temperature of a material changes, its strength also decreases. You may be aware about one of the well-known story of Titanic, that is Titanic ship. So what happened in that Titanic or Titanic ship, that it was designed in such a way that even the temperature even it will hit with the iceberg, the structural damage will not be will not take place. But even after designing for the impact on the iceberg, that design consideration was already there. But when in actually that ship hit with that iceberg, it is a crack is developed, and ship we know that it is broken into two pieces, and it is went down in the water. So what was the root cause under it? Because that impact was already considered. So why it is failed? Why there was a crack development? So one of the reason was the temperature. The ship was designed for the impact of iceberg, but the designer didn't consider the temperature at which the ship hit the iceberg. Because when that ship hit that iceberg, the temperature was negative. It was in minus. And we know that when a ductile material is subjected in minus temperature, then it will behave like a brittle material. So the strength of the material will decreases. Take other example, if we increase the temperature of the material, what will happen? Again, the strength of the material decreases. So in case of Titanic ship, one of the reason of failure was the decrease in strength of the material due to low temperature. And the behavior of the material, even though the ship material was ductile, but due to decreased temperature, it was behaving like a brittle material. So that was the one of the reason. So therefore, whenever we are deciding to use any material, we should test it under different temperature conditions, and for different temperature you will get different value of, let's say, ultimate tensile strength. Again, by using these two values, develop a equation, and you may be find out what will be the strength of the material at 1000 degrees Celsius temperature, and accordingly you can design the component or, for example, ship. Similarly, from this equation you can find out what will be the behavior of that material at minus 50 degrees Celsius temperature. So this is another example where the empirical relation needs to be developed for, and that relation can be used for design. Let's take an example of aeroplane. So when that aeroplane will be on the ground, the atmospheric temperature will be the 20, 30, 40, 45 or 50 even. And in European or uh, American countries, for example, US or Canada, the temperature will be minus 40, 50, 60 also observed. Again, when that aeroplane will be in the air, again temperature will go down to minus 50 or 60 degrees Celsius. So whenever you are designing the body of that aeroplane, you must consider the operating temperature, and accordingly you need to select the material and carry out the design calculations. So this is another example. Again, you already perform some experiments on turbines or pump, and what you did for different speed of water jet, you calculated the turbine efficiency. So in this table you can see the speed and corresponding efficiency of the turbine. And as an engineer we are always interested in maximum efficiency. So from this table you can observe and you can develop a equation for speed of the water jet and efficiency. And when you develop that equation, you can find out the speed at which maximum efficiency will be there. And this particular data will be your input, and accordingly you will design your turbine. So a prototype will be developed, tests are performed, relation will be developed, optimum conditions or parameters are identified, for example speed and efficiency, and based on that actual model on the site will be erected or developed for maximum efficiency. So these are the three examples will give you some idea why there is a need to develop empirical laws for design and operation point of view. Now next question is how to fit a curve for a given data. So these are the questions. So slowly we will go inside it. We understood that there is a need of developing empirical relations or curve fitting or regression analysis. Now how to do it? So the first example is least square regression. So what is done? The value of x and y or x and f of x will be given to you. You will plot it on the graph paper. Once you plot it, you will draw a straight line in such a way that the distance between the line and the data point will be as minimum as possible. So that care we take and we draw the straight line. So this method is called as least square regression, and this line will have some equation. Let's say y is equal to mx plus c or a plus bx. So we can say that this particular equation we get by using straight line, and then in future you may be interested to find out what will be the value of y when x is something here. So this particular method is called as a least square regression. Second is linear interpolation. What is done in linear interpolation? The data points are joined by means of a straight line, and accordingly you can do some prediction. So when you connect these data points by means of straight line, and if you find out the value of y for a given value of x, then you can find out. So if you are adopting this type of approach, then it is called as linear interpolation. You may think of connecting the data point instead of a straight line by a curve. So the data points you can see here are connected by means of a curve instead of a straight line. So this is called as curvilinear interpolation. So if you adopt this method, then it is called as curvilinear interpolation. And again, in this case, suppose if you are interested in a value of f of x for a given value of x, then by using this method, you can find out the value of f of x. So these are the some of the approaches that can be used to fit a best curve through the 5 data points in this case. If there are more data points, you can expand the same. So the process of finding the equation of the curve of best fit, which may be most suitable for process predicting the unknown values, is known as curve fitting. So this is the generic definition for curve fitting. For the given data, we fit a curve or a straight line so that the error will be least. And by using that equation, we can predict the values. And that is called as curve fitting. In simple words, curve fitting means an exact relationship between two variables, say x and y, by algebraic equation. So this is another simple word. So just find out the relationship between x and y. We will move ahead and we will go to principle of least squares. So try to understand this principle, because this principle is very, very important. And if you have any doubt in between, you can unmute and ask me, because if you didn't understand this principle, you may not understand the latter part of this particular unit. So this is very important, and we will discuss there. We will take your questions and then we will stop. So the principle of least square provides an elegant procedure of fitting unique curve to a given data, and it was suggested by French mathematician Adrien Marie Legendre in 1806. So you can imagine, long back this principle has been developed. And what is essential? First, data points. Second, what type of curve you want to fit for the given data. So these two points are very, very important in least square technique. Okay, so and how it is carried out? Consider data points x1, y1, x2, y2, x3, yt up to xn, yn. So these are the n data points. And we want to develop the relationship between x and y. Data points are there in terms of x and y, and we want to find out the relationship between these two. So what we will do, on x-axis we will take the value of x, and on y-axis we will take the values of y. And we have plotted x1, y1, x2, y2, x3, y3, and up to xn, yn. So if you have a data points, then by taking appropriate scale on x-axis and y-axis, you can easily plot those points. Now, once you plot those points, you need to draw a curve. You can see a curve which is denoted by y, and that may have a equation of y is equal to a plus bx plus cx square up to k x raised to m. So such type of equation or curve you can fit for the given data points. And when you plot this curve, what is very important? The error. And what is that error? The actual point which is here and the corresponding point which is on the curve. So whatever difference between the actual point and the corresponding point on the curve is nothing but the error. That error should be as minimum as possible. So that care we need to take off while drawing a curve or fitting a curve to the given data set. Why I am telling this? Because after getting that equation, when you put suppose x1 into that equation, in this equation put x is equal to x1, then the equation will give you which point? The equation will give you this point, that is value of y corresponding to value of y1 corresponding to x1, and this y1 is based on your equation. But in actual practice, your actual y1 will be here. This is the correct y1 and this is the theoretical y1. And whatever difference between this actual and theoretical value, it is called as error. So E1 is corresponding to first point, E2 is the error corresponding to second point, E3 is error corresponding to third point, and so on. So these are the errors, and our ultimate objective is to have minimum values of these errors so that accurate predictions can be made. Because suppose take any random point, say xa, let us say xa is any random point, and when you put x is equal to xa in this equation, you will get some value of y on the curve. That will be here, right? But in actual practice, that point may be either here or here somewhere, right? But if our curve is best fit, then whatever error will be there, that will be minimum. And this is our objective, so that we can predict the new value or unknown with a greater accuracy. Now, once you fit this curve, then how to make sure that it is a least, there is a least error, it is a best fit. So if we start adding these errors, then the total value will be the total error, and our objective is that total error should be as minimum as possible. Now we cannot add this error value directly. Why? Because if you look at this error E1 and point x1 y1 which is above the curve, so that will have a positive sign, for example. Then if you take the value of E2 corresponding to x2 y2, then this is below the curve, so that will have a negative sign. Again this point will have positive sign, this error will have positive sign. Suppose there is another point here, so that will have, that error will have negative sign. So there is an issue of sign. So what we do, we take the square of errors and then we take its sum, and that's why you will convert the given error value into positive signs, and then we calculate the total error, and our objective is to have the minimum value of this error. And the curve of best fit is that for which the value of EY, that is E1, E2, E3, that will be as small as possible, and sum of the squares of the error is minimum. So we are taking the squares of each error and then we go on adding those. So that's why they are called as sum of square of errors. And this is nothing but the principle of least square. This is nothing but the principle of least square. So in brief, I will take a review of this concept, principle of least square. What we do, we have data points x1, y1, x2, y2, and so on. We plot these points on the graph paper. So you can see x1, y1, x2, and so on. Then we draw a curve and develop its equation y in such a way that the error E1, E2, E3 will be as minimum as possible. And when you get such equation, then this process is called as principle of least square. That is, the total error associated with the curve will be minimum or least. Okay, so that's it for from my side for this particular session. So if you have any question, the session is open for discussion. Yeah, if you have any question, you can ask.